Hi, hello, good morning, welcome back to my channel. So, as promised in the previous lesson, today I'm going to start with important numerical problems related to refractive index. But make sure that you're thorough with the theory part of refractive index so that you will be able to solve the numerical problems quickly. So, are you ready to begin? Yes. So take your book, pen, and get ready to write the answers in your notebook. So let's move on. Yes, so here is our first question. Let's understand what it is. A ray of light starting from air passes through medium A of refractive index 1.5. Okay, so the medium A has refractive index 1.5. and enters medium B. B has refractive index 1.33 and finally enters medium C of refractive index 2.42. So medium C has refractive index 2.42. If this ray emerges out in air from C, it is coming back to air. So it started from air and going back to air. Then for which of the following pairs of media the bending of light is least? Okay, it's a very good question. So we have already learned about the relation between speed of light and refractive index. So what is the relation? Yes, refractive index is inversely related to speed of light. More the speed, less the bending. Less the speed, more the bending. Okay, so let's understand this case better. So in the first case, light is entering from air to A. Second case, A to B. Third case, B to C. Then C back to air. Okay, so these are the different situations given. Now, for air, we take the refractive index as 1.0. Okay. And for medium A, it is already given 1.5. Medium B is 1.33. And medium C is 2.42. And air is 1. So, in order to understand in which of the pair of media that the bending of light is least. So, I'm going to give you a shortcut way to do this. Okay, so here we have different pair of medias. Now, let's find the difference between the refractive index. Okay, so if the change in refractive index is smaller, then in that case bending of light will be least. Okay, so let's see which has the least bending. So in the first case, when you find the differences, so you will get the differences as 0.5. Yes, now here if you find the differences, what will you get? Is you will get the difference as 0.17, 0.17. Now what about the third case? So here you will get 1.09 as the differences. Now the last case you will get 1.42. Okay, so these are the differences in the refractive index when light entering from one medium to another medium. Now compare the differences. In which medium, in which pair of media do you think the difference is least? Yes, this is the least differences. So what is that pair of media? That is A to B. So our right answer is option B. So A to B, bending of light is least because the difference in the refractive index is least. So you can find the change in refractive index. Okay, this is the shortcut way of finding the answer. For MCQs, you can use this method. Okay, otherwise you can just compare which is denser, rarer. So here air is rarer, denser. Here when you compare these two, this is denser, rarer. Then when you compare these two, this is rarer, denser. This is denser, rarer. Okay, so in the second case, again you can see denser to rarer bends the least. That is another way of explaining, or scientific way of explaining why bends least when light travels from A to B. So now let's move to the second question. Yes, in the diagram shown above, okay, so here you can see the diagram where different refractive indexes of medias are given. So there are 3 medias, 1, 2, 3 with refractive indices N1, N2, N3. Now which one of the following is true? Okay, so here options are given. Now you analyze the diagram. Okay, so here N1, N2, N3, 3 different refractive indices are given. Let's compare N1 and N2. So when you compare N1 and N2, you can see that there is a slight bending when light enters medium 2. So since there is a bending, we can say that refractive index of 2 is greater than 1. Now when you compare N2 and N3, again it bends more towards the normal. So refractive index of 3 is greater than refractive index of 2. Now we have one more option given here, N1 equal to N2. That is not possible because there is a slight bending. So this one, so option A is not correct. Now see, N1 greater than N2, N1 greater than N2. No, why? Because light ray bends in medium 2. So if it bends in medium 2 compared to 1, which means that refractive index of 2 is greater than 1. So this is not right. Now let's see the third option. N2 greater than N3, 2 greater than 3. Again it is not possible because in medium 3 light bends more compared to 2. So definitely 3 is greater than 2. So this is not the option. Now see the last option. N3 greater than N1. So you are comparing 1 and 3. Yes, it's starting from 1. When it reaches 3, it bends more compared to medium 1. So what does that mean? Refractive index of 3 is greater than refractive index of 1. So the right option is D. Okay, so wherever you see more bending of light, which means that refractive index of that medium is more. Now let's move to the third question. Yes. So water has refractive index 1.33 and alcohol has refractive index 1.36. Which of the two medium is optically denser? Give reason for your answer. Okay, so let's understand one by one. So here they have given refractive index of water. So NW is given as 1.33. Then refractive index of alcohol. So N alcohol is given as 1.36. Now which is optically denser? So the medium which has more refractive index is optically denser. Yes, more refractive index. More refractive index is optically denser. So compare these two. When you compare these two, which is optically denser? Yes, alcohol is optically denser. Why it is optically denser? Because the refractive index is more compared to water. So alcohol is optically denser because its refractive index is greater than water. Okay. Now B is draw a ray diagram to show the path of ray of light passing obliquely from water to alcohol. So this is A. Now B, we have to show diagrammatically, ray diagram. So interface, I am drawing normal. This is water and this is alcohol. Now light rays entering from water, that is refractive index is 33. alcohol 1.36. So this is optically rarer, optically denser. So what happens to ray of light when it enters from optically rarer to optically denser? It will bend towards the normal. Yes, so light ray bends towards the normal. Now state the relation between angle of incidence and angle of refraction in the above case. Yes. So we have already discussed about this in previous module. So what is this angle called? Angle of incidence. What is this angle called? Angle of refraction. So when light ray enters from optically rarer to optically denser medium, what is the relation between I and R? Absolutely. Angle of incidence is greater than angle of refraction. So the answer to the third question is angle of incidence is greater than angle of refraction. Why angle of incidence is greater? Because light ray is entering from rarer medium to denser medium. So it bends towards the normal. In that case, angle of incidence is greater than angle of refraction. Let's move to the next question. Yes. So the refractive index of medium A is 1.5. Okay, medium A is given as 1.5 and medium B is given as 1.33. If the speed of light in air is 3 into 10 power 8 meter per second. So speed of light in air is denoted by C. Okay, that is speed of light in air. Speed of light in air, that is given as 3 into 10 power 8 meter per second. Now you have to find what is the speed of light in medium A and medium B. Wow. So refractive index is given, speed is given. So what formula you can use here? Pause the video and try it by yourself first before I explain the answers. Okay, so let's see what will be the speed in both the medias. So first we have absolute refractive index n equal to C by V. Okay, so medium A, NA is equal to C by VA. Now what is NA? That is 1.5. C is given as 3 into 10 power 8. We have to find VA. Now you can just take VA transpose, then take 1.5 to the denominator. Now when you simplify this, you will get 2 into 10 power 8 meter per second. So this is the speed of light in medium A. Now what is the speed of light in medium B? Again, you can use absolute formula NB equal to C by VB. So NB is 1.33. So VB is C by, so we have C as 3 into 10 power 8 divided by VB. So VB is equal to, just cross multiply, so you'll get 3 into 10 power 8 divided by 1.33. Yes, so when you simplify this, you will get around 2.25 into 10 power 8 meter per second. So this is VB. Now let's see the next question. Yes. So here the refractive index of medium X with respect to medium Y is 2 by 3. So how we can write refractive index of X with respect to Y? Yes. So refractive index of X with respect to Y. So NXY, which is equal to 2 by 3. Or you can write NX divided by NY, which is equal to 2 by 3. Now, and the refractive index of medium Y with respect to Z. So Y with respect to C, which can be written as NY by NZ, which is equal to 4 by 3. Now you have to find the refractive index of medium Z with respect to X. So medium Z with respect to X. So you can write it as NZ by NX. So this is what we have to find. So how can we find? Just pause the video, then try it by yourself. Yes, okay, I hope you tried the question and you got the answer. Let's see. Now we want NZ by NX. So we have NX by NY and we have NY by NZ. So using these two informations, we are going to find what is NZ by NX. So I think we can just try by multiplying. So NX by NY into NY by NZ, which is equal to 2 by 3 into 4 by 3. So you can cancel out the common terms, that is NY you can cancel out. So you will get NX by NZ, which is equal to 8 by 9. But our question is NZ by NX. So just take the reciprocal of this. So NZ by NX will be equal to 9 by 8. So this is the refractive index of medium Z with respect to X. Now we have to find, there is one more question here. If the speed of light in medium X is 3 into 10 power 8 meter per second, calculate the speed of light in medium Y. Now we have to find what is the speed of light in medium Y. So I'm just erasing this. Speed of light in X, that is 3 into 10 power 8 meter per second, and speed of light in Y we have to find. Okay, we don't know what it is, but we have the relation. Refractive index formula is given. Nx by Ny is equal to 2 by 3 is given. Now we have the relation between refractive index and speed of light. What is it? Nx by Ny is equal to Vy by Vx. So we already have Nx by Ny, that is 2 by 3. So just substitute. Now Vy we have to find. Vx is given 3 into 10 power 8. So you can just cancel out 3 and 3 and take 10 to the power 8 to this side. So what will be your final answer? Vy is equal to 2 into 10 power 8 meter per second. So this is your Vy. So hope you got the same answer. Yes. So next question. So it is an MCQ. Let's see. So consider these indices of refraction. So they have given glass, air, water. So based on the refractive indices of 3 materials, arrange the speed through them in decreasing order. Okay, so we already learned about the relation between refractive index and speed of light. So what is the relation? N is inversely proportional to speed of light. So here N glass is given 1.52, then N air is given 1.0003, then N water is given 1.333. So in which medium do you think the speed of light is greater? Absolutely, speed of light will be greater in air, because compared to glass and water, refractive index of air is less. So speed in air is, So first, speed of air is greater. Then who will come second? Water, refractive index of water. So compared to glass, this refractive index is less. So after air, you will have to write water, speed in water. Then last is speed in glass. Why? Because this is the relation. Refractive index is inversely related to speed. So more the refractive index, lesser will be the speed. So glass will come at the last. So this is the decreasing order. We have to write decreasing order. So this is the decreasing order. So what is the right option here? Yes. Speed in air, speed in water, and speed in glass. This is the right option. So that's it for today. So we will meet again with another interesting topic in our next module. Till then, bye.